You're able to see my screen?
Yes, sir. We are able.
So what I want to do today is explore more of functions. And yesterday we saw just a brief introduction of functions. So when you write functions, the first part of the function will be the return type, then name of the function, and there would be a bracket. Then here list of arguments along with their types, and there will be a flower bracket and there will be end flower bracket. So just to give an example, we have dealt with computing area of a circle. So if I were to compute area of a circle, we know that area of a circle turns out to be a real number. So I say return type is float, and you can say give a meaningful name to the function. Let's say compute area. Then we require the radius of the circle. So data type, then name of the variable, and within this I have to do the computation. I can, since there is only one step in computing area, I can directly say return pi star rad star rad. So in this case, the pi value, of course, you should have defined in the header section. Now here you are taking pi as 3.142, which is by default stored as double data type, because if you don't mention anything, it is double data type. If you want to be float, then you put a letter F here so that it is float. So the whole computation will be in float, and you are returning that value as the return type. Okay. So this is the simplest form of a function. Now certain functions don't return anything. For example, you just want to display some value passed to the function. Let us say show me, and you are just passing some variable A. So this is not returning anything. So here you will only have statements, uh, computational statements, or maybe just a print statement, depending on what you want to do, and that's it. So there will be no return statement here. Okay, so if it is void, there will be no return statement. But if it is anything other than void, int, char, float, then there should be a return statement. Okay, and C has a peculiar uh, default value return. That is, if you don't mention anything, any return type. For example, if I say compute fact, that is factorial of a integer value, then I need not say int here. If I don't say int, by default the return type is int.
So, sir, this applies to main function also
Yeah,
if we
yeah,
don't.
it applies to main also. So if you don't mention any return type in main, it is expecting a int return type.
And similarly, I can give a return type as void also.
Yeah, void also in the main. We'll see all those variations. Okay, so functions should have a meaningful name. If you don't mention any return type, by default it takes it to be int. Okay, and it can take any number of arguments here separated by comma along with their respective data types. Okay, and what you do here depends on the program logic to implement that function. And normally function does only one task. Okay, so don't do too many things inside a function. So the reason is, by looking at the name of the function, you know what exactly it is doing. So you cannot say compute fact and within this you are computing factorial and also finding whether number is prime or not. So don't do such things. So don't mix up the computations. Just keep functions uh, assigned to only one task at a time. So you can have any number of functions, each function doing a particular thing. Hmm? All right. So let us see how all this works out in the program. So as you all know, we are all familiar with computing radius. We shall take something else. For example, you want to do factorial of a number. Okay. So we require the value of n, let's say 5, and I want the result, which is again an integer. And I'll write a function compute fact or just fact. Okay, and you have to pass the variable here. And when you pass the variable here it is called as formal parameter. N is called as formal parameter. And when you actually implement the function, like now compute fact is returning an integer value, I need not specify the return type. So compute fact. However, the data type of argument has to be mentioned, n. And since you're calculating factorial, as you know, you require some initial value of fact, like int fact equal to 1, and you iterate this through a loop for I equal to 1, I less than equal to n, I plus plus. Of course, this initialization is not required. I'm doing it here. Just a variable declaration has to be there, int I. And within the loop, I say fact equal to fact into I. So what I'm doing is I equal to 1, 1 to 1 into 1, then I becomes 2, 1 into 2, that 2, then I becomes 3, 2 into 3, 6, like that it goes. And once the computations are over, you have to return the result. So you have to say return fact. So as you can see, there is no return type. Ideally, you should have written like this for clarity, but if you don't write anything, it always expects int return type. Okay. Now before you call this function, you need to write the function prototype. Int compute fact and then int here. Okay, so now we want to print the result after you get the result from the function. Here factorial of percentage d is equal to percentage d. So you want the factorial of n, so n will come first and then the result. So now if I run the program, hopefully factorial of 5. Now here the default is int, so you have to, if you mention the prototype int like that, this particular compiler is expecting the prototype and the function should be exactly same. So if you write default return type and then write it like this, it will show some warning, not that it is an error. Yeah, so as you can see, return type defaults to int, just a warning. So you can ignore this, you'll get the result. But if you want to suppress this error, you match up the definition of the function with the prototype of the function. So this is called as function prototype, and this is function definition. And the value, the variable n here is called as, I think so, this is formal and this is actual. Has anybody has some idea? Is this actual? I think so, this is actual and this is formal. Yeah. So as you could see, we are doing only one task here. And you can write any number of functions here. Okay, for example, you want void show some int result like that. Printf percentage d. So here it is not returning anything. So the prototype again has to be void show expecting an integer value. So here, if you want to invoke this function, you would write show and pass some value, let us say n. And to just separate out the things, I will put one slash n. So this show function simply prints the value of n. Okay. And as you can see, there is nothing coming back from the function. There is no variable x equal to something, as in case of compute fact. Compute fact is returning a value, so there will be a L value. So variable result is called a L value. So it is receiving the value received by the computation. Okay. So you can write functions which take any number of arguments and return. Remember, functions will always return one value, at the most one value or no value. That we must note. Functions will return at most one value, and the worst case no value. Okay. Now instead of writing all these functions and main in the same file, you could keep these functions in another file. We'll see that shortly. Now, one of you raised the question, what happens if I don't do this? That if I remove return type of main, will it be by default int? So program should still run, right? So as you can see, if I don't mention the return type of main, it's still running. Okay, but if I say void, this time it will give error because you are returning 0 here. Yeah, it is giving a warning. This is not an error, but it is a warning that the return type is void and you are trying to return. So if I remove this statement, then that warning would go away. Yeah, good. So it's good for me to get a better picture of all this. But only thing is, I'll not be able to see that project window. Anyway, that is not required. Now, what I do is I can put those functions in another file, right? So to do that, you say new file here and give some file. Let us say all funds and .c. Okay, and I'll just copy all these functions here. I cut this, so I remove completely from main and put them in this file. Okay, now only change that is required is since in the second function I'm using printf, so there should be a hash include stdio.h, isn't it? Okay, so that's the only change that is required, right? So now if I run, the program would still run, correct? So that is because even though your functions are in some other file, the function prototypes are here. So both the files are individually compiled, and when you compile this main file, it just remembers the signatures of the functions, and when individually compiled files like main.c is compiled separately, all funs is compiled separately, and they are linked. So there is a process of linking. At that time, the addresses of these two functions which are in another file are linked, and then the functions are called. Okay, so I have not shown you the detailed process of compilation. There are in fact 3 to 4 steps. We shall take up that sometime later. That files are first compiled into what are called as object files, and individual object files are all linked together to generate the final executable. So here function prototyping is a must. Suppose if I remove one of these, let us say, now it fails to compile, as you can see. Okay, so it doesn't know where that show function is. Okay, so it is giving again warning. Since it is in the same project, it has somehow resolved it. Okay, so if you are missing the function prototype, again it gives a warning. You have to keep the function prototype so that your program runs without any warnings. All right. So function prototyping helps the C to strictly check the data type. So as I told you that C is strictly typed language, isn't it? Some time back I told you like this. What do you mean by strictly typed language? It means when you are say compute fact n. So what you might do is while you are sending n here, you may send float, no, by mistake. Possible? Is this possible or no? Suppose if I send float n equal to 5 and compute n is expecting a int, then what will happen? It will say, it will again give you a warning that there is a mismatch of data type. There will be a, now there is not much of a loss because this is uh, upgrading the value from the value given is 5 here, but suppose if I send 5.5, okay, now this time it's going to be, the value will be truncated, so there is a loss of precision when I do this. Okay, so a strict type checking is done and you will get warnings if those type checkings are not correctly matched. Okay, so it is always a good practice to see that the data types are correctly declared and used in the function invocation. So this is a function invocation point. Okay, now here the function we say it is called. Okay, we say function is called. What is the meaning of this? Function is called. It means the control, as you can see, when the program start executing, it will start from the main here, and step by step it will go. It will come to this declaration, initialize n to 5, then go to the second instruction. When you come to second instruction, the control should go to this function, right? Compute fact. It will start executing here like this. And once you say return, it will come back to your main function here. It will be back with the result and you're displaying the result here. Okay, so how does it know that it has come back to this statement here? Okay, so before the function is called, every, as I told you, every variable has a memory address, isn't it? So also every statement has a memory address. So here every statement has a memory address. Let us say this is some 9,000. This line has 9,000 address, and let us say this is some 9,005 or something. So what happens is the program, while executing, it will remember this return address by pushing this address onto, there is a data structure called a stack. You're all familiar with stack, if I guess. So on the stack, it is going to store 9005 and then switch to this function here. Okay, and when you say return fact, at that time, it will again go to the stack, pull out this 9005, and then it remembers that it has to come back to this line. And then it gives a printf statement here. Okay, so if whenever you make a function call, remember something will be pushed onto stack. In fact, I've just shown pushing of only the address. Along with the address, all the arguments that are passing. For example, you're passing n, no, to compute fact. So that will also be pushed onto stack. Of course, the stack has to be properly displayed vertically. And just for simplicity, I'm putting it alongside. So remember one thing, whenever functions are called, there is some overhead associated. It means it will take some time for the function to make all these preparations before branching out to the function that is being called. Okay, so mainly it will remember the address of the next instructions in the stack, and also any argument that you're passing. If there are more than one argument, for example, there is one more argument x here, so even x will be pushed onto stack. right? And when you come back, these nx values will be available to you to use here. So for now, we'll keep it back like that. So remember that even the instructions in your program has memory addresses, because your program will be stored in memory and one by one the instructions are fetched. Every instruction has a address, and that address of each instruction will be known to the CPU. It will store it in one register called as program counter, and when you make a call to a function, the next address of the next instruction will be pushed onto stack, and only through the stack it knows where to come back after executing the function. All right, so behind the scene there is a lot of things happening, and you should know what exactly happening when a function is called. Is that point clear? Hello?
Yes, sir.
Okay. Now there is one point which you need to understand, that there can be some functions which need not be working like this. That means that they need not use stack, go to that function and do the computation. Such things are called as macros. So macros look like function, but they are not called. Okay, so let me define that and show you. For example, I want to find maximum of two numbers. So I can write max int a comma int b. Okay, and here what I do is I say return a greater than b. So there is a ternary operator, if you remember, right? Then it will be a or b, like that. I think so. This return is not required. So as you can see, this max also looks like a function, isn't it? Suppose if I write it here, let us say int c equal to max 5 comma 7 or 5 comma 6. Now what will happen to this value of c? It will be 6, right? C equal to percentage d comma c. Yeah. Now, as you can see, this compute fact and max, they look the same, right? They are looking like functions only, but max is not a function. Max is called as, what is macro, we shall see shortly, and what exactly happens when I define a macro like this. So if I run the program, yeah, as you can see, c is equal to 6. Now, the macro invocation point, it very much looks like a function call, but it is not function call. So how macros are different as compared to functions? So what happens is, this macro, when you specify here, the control will not go here. Okay. So as I told you, there is a pre-processing that takes place. So if any macro is there, then in the pre-processing step of the compilation, this max 5 6 is replaced with the macro definition, that is 5 greater than 6. Then it is going to be 5 colon 6, like that. Okay, so what it does is 5 greater than 6? No. Then the return value will be 6. Okay, so
Sir, what about in the case of read from the function? Meaning, if we have generated the particular, if we are taking the input from the scanf,
yeah,
so in that case,
that is also fine. For example, you are reading two values, right? A, B or X, Y, let us say, and you are reading scanf percentage D ampersand X comma ampersand Y. You want to read two values and pass these XY values to the macro, right?
right?
Is that what you're asking?
Yes,
Yeah,
yes.
max X comma Y. So here also it should work fine. So I'll put one prompt here, enter two integers. Okay, so now let's see. So it is expecting us to enter two values, let us say 11 and 9. So what should happen? 11 should be maximum, C equal to 11, isn't it?
Okay.
Okay. So macros are called as inline functions. It means the substitution happens. The expression here will be, what actually happens is this max xy will be replaced by x greater than y question mark x colon y. So instead of you writing x greater than by x colon y, you are making use of a macro like this. The reason why we want to do this is, suppose there are many places where you want to find maximum of two numbers. Then every time you have to write that ternary expression. Instead, you write it once and use it many times. So this macro invocation does not use stack, whereas function invocation uses stack. Okay. So are you clear with the distinction between function and a macro? Oh, okay. See, I'll illustrate that through example like this.
Okay.
Now, you know you have a function,
Okay.
let us say void 1. You are just printing something here, hello. Okay, and this is your main, and you're calling this function fun.
Okay.
Here you have other statement 1, 2, like that. Now when you make a function call, the control goes here.
Correct.
The execution starts here, and then when it ends, it will come back to this statement. Now for the computer to know where to come back after the control is transferred to the function, it should remember the return address. This is the return address.
Okay.
This, let us say this is some 9005 or something.
Okay.
And there will be a stack like that. Stack is a data structure which is built-in stack, where it pushes the value 9005 before branching to the function. Okay. And see, this is the central processing unit which will be fetching the instructions and executing, isn't it? So for fetching, it should know the memory address, isn't it? So whenever you make function call here, this function also has a memory address, let us say some 9800. So CPU fetches 9800 and then it start executing the statement from here. The hello is done, but when it reaches this point, it should get back to 9005. No?
Okay.
So what CPU does, it will take, whenever it reaches the end of the function, it will consult the stack, and whatever is there on the stack 9005, it will take that and then start fetching. It means statement S1 will be executed next.
Okay.
And then it proceeds like that. So this is the function call, what we call it as overhead. It means there is some computations that have to be done when you make a function call. It means something has to be pushed onto stack, and then something has to be popped from the stack and all that. And if this function is using some value n, let us say you declared int n here, okay, then obviously int n should come here also. This n is also pushed onto stack. Why it is pushed, where it is used, we shall see later. But stack is used, and before it returns back to the main function, this all popping happens and there is a overhead associated. Now if very small things have to be done, like finding maximum of two numbers, then it is better to write a macro to avoid this overhead. If you write a macro, then you will save a lot of time. So if you write a function to find maximum of two numbers, how would you write? You write int max int a x comma y, right? Like this you write. Here you write if x greater than y, return x, else return y. Hmm. This is your function. Now macro can also be written in a more shorter way. Just you have to say hash define
Okay.
max x comma y. Don't write int x int y. Just say x greater than y. If x greater than y, you return x. Otherwise, there should be a question mark here. This is called ternary operator. In my video, I have mentioned this. It means it will compare x and y. If x greater than y, it will return the first one. That is, otherwise it will return the second one after the colon. So what will happen here? If you are passing, let us say, if I say max 5 comma 7. If you call a function, let us say this is not there, you are calling a function. It will go here, it will do all the if statement and all, and you will get the int c, whatever is the result. So this call return business will happen if it is a function.
Correct.
But suppose if it is macro, if you are using this one, then this whole thing is replaced using this macro expression. That is, in place of x here, the 5 will come. In case of y, 6, the 7 will come. Question mark 5 colon 7. So now 5 greater than 7? No. So it will go to the else part and it will return this 7 and C gets 7. So there is no call to the macro that is happening.
Okay.
Understood?
Yeah. Got it.
Yeah. So macros are faster compared to functions. That is
Function.
important. All right?
Yeah.
Okay.
Thank you.
Okay. So any doubts here?
Sir, we'll write one program, sir.
You'll write one program. That's good. Write any one program. Let it be adding two numbers and sending the result, or finding remainder of a number by dividing two numbers. What you can do is find remainder. You can write by passing two values. Okay, you know how to find the remainder, right? But write it using a function. Let me see.
Okay.
Who can do this?
It should be A mod B or B mod A.
A mod B.
Okay.
Or you can check whether A greater than B, do A mod B, otherwise do B mod A.
Sir, I had this doubt.
Okay.
See, str1, like we are setting it to some string,
Okay.
and we are creating a pointer. What is the difference? Like here also, the third line is creating a pointer also, right?
Yeah.
Same.
Yeah, I'll tell you that. Okay. So if you are in the chat box, I can tell you. See, what is happening here is, if I say str1 of Faisal, then it is allocating space in read-write memory.
Oh, okay.
Okay. So you can change the content of memory by using the index. For example, str1, let us say str index 3 equal to some character C, like that. So now what happens is, the fourth index 0, 1, 2, 3, that is S, will be changed with C. Okay. So just to pay attention to the screen here. So you should have declared two variables, int a equal to 5, let us say 9, and b equal to 3, b equal to 2, and let us say I want to store the result in C. So C equal to find the remainder, like that, and you want to print C here. C equal to %gc, and you would write a function int find remainder a comma int a comma int b. So this syntax you should get acquainted. Okay. And here you should say return a mod b. Okay, and function prototype, you'd write int find remainder, then int comma int, semicolon. All of you have done this? Just see. And if
Sir, I pasted the code. Can you please check?
it's working, right?
Yeah.
Yeah. See, writing functions, you should practice more, and any requirement comes, you should be able to know what is the input that is being given and what output is expected, what is the return type and all that, and you should write a function prototype. So you could have written macro to do this, right? Let me show you hash define find rem. I will only write find rem, and here I write a comma b, and here a percentage b, and instead of this find remainder a comma b, I would now write find rem a comma b. Should it work? Let us see. So this also gives me correct c equal to 1. Now the difference is macro will be substituted in line, okay, and function is called. Okay, it means it involves stack. Okay, so it means if you use a macro before compilation, this step will be replaced by a mod b. That is all. Now you all might be wondering why you should write a function to do find a remainder. Just an illustration that you could write a macro or write a function depending on the need. As you can see, because this is a statement, the control is not going anywhere. It is doing a mod b right here. That is why it does not involve any stack. Okay, so this is called as macro substitution. All right. So, but the look you get is that of using a function. So, or else you can put them in one header file and include that header file.
Okay.
That can be done. Yeah.
Okay.
All right. So we are good here, and we are able to distinguish between macro and function, and we know how to write a function given the problem statement. So one more important thing that you must learn when you use functions or when you write functions, how do I deal with arrays when I pass arrays to a function, or can I pass array to a function, and if at all I am able to do, how can I do it? So let us say we have some items here, okay, and we know how to initialize this items and their quantity, something like that. And how many items are there, we can always calculate by using size of operator. See, size of is not a function, it is an operator. Items divided by size of
int.
Yeah, size of int. That's good. Okay, so now we know how many elements are there. Now, if I have to pass this array, okay, and the number of elements, I want to do some computation that maybe just add up all these items. So I can write a function find sum. Now the way to pass array is just mention the name of the array, and second argument just the name of the variable. But when you, and if it is returning some value, you have to hold it in some result. Let us say int result equal to. So find sum will return integer result. So I write find sum here. Now how do I mention to the compiler that the first argument is an array? So here you should specify the data type, then name of the variable, then a square bracket, empty square bracket. Okay, So in the function declaration, or function definition, the array has to be mentioned like data type of the array, name of the array, and then square bracket. Okay. So compiler understands that the first argument is an array, second is a normal variable. All right. Now here, if you want to sum up the things, you can set up a for loop for I equal to 0, I less than n, I plus plus. Then to sum up the values, you require one variable sum, which is initialized to 0 initially. Then here you can put sum plus equal to, as a short form, your items 5. And then before you close the function, you say return sum. Okay. So when you pass an array, right, the array name, we know it is a pointer, isn't it? It's an address. So the address gets copied in the items and it refers to the same array which is in main. It will not get a copy of the items in the function. Okay. So now if I run the program, yeah, you have to remove this. And then I think so we have to remove that function prototype also and add the prototype of sum. So int find sum. So how do you mention here? Can you guess what should be the function prototype? Int?
Int star.
Huh?
This star.
No, not int star, int square bracket,
Correct.
then int. We can say int star also because that is an address. Should it work? Let's check. It does, but it's not showing any output. Let us see, is it because of this one? Oh, I'm not printing anything. Sorry.
Print.
Yeah,
Yeah, print this is not
yeah,
given.
I'm not printing anything. So, comma result. Yeah, now it should work. Yeah, result is 75, and even if you do int star, it should work because array name itself is an address. Yeah, it does. Okay, is this clear?
Yeah.
So this will be the same in the case of char string, char array
Yeah,
as well,
char
right?
array also. Char array also. Now just
Shall
to,
we,
yeah,
shall we try this?
yeah,
No.
yeah, you can try. You can try. So, you can try in the meantime. I will explain what
Sure,
is
sure.
really happening. Yeah,
Okay.
what is this one? Yeah, find the sum of some numbers given as items here.
Yes.
Okay, good. Now I have one small explanation here. See, this function which we just now saw, we know you're able to see my screen, right?
Yes.
Okay. Now see, you need to understand what all is happening here. In the main as a scope, it has its own memory. It extends from year to year. All of you agree? This is a
Yeah.
domain of main. So when I declare items, this item got allocated memory, maybe at 4000, let us say, and you got your first number 11 here, 4004, your next number 8, like that, some 4000, let us say 12 or something, and the last number is. This is how memory is allocated, right? Yeah. Similarly, your n you computed, and that also got 4014, sorry, 4004 bytes, no? So 4016 here, and n is how much? 1, 2, 3, 4, 5. So this is 5. So there are 5 elements, so you got 5. Hmm? Yeah. Now you are calling this find sum with 2 arguments, right? And you are declaring a parameter items here, function parameter, here also n. Now this function has its own scope of memory, right? It is extending from year to year. Now what will happen to items? Okay, so items will also be declared here. Hmm? And n will also be there. So do you think this entire array will be copied here, or only the address of the array will be copied?
Address.
Okay, so all of you agree it is address?
Yeah, as arrays are pointers, right?
Yeah, because array name is a pointer, and
Correct.
you need only copy the address so that you can access this part of the memory from being inside this function. Whereas the value n is not a, it is not an address, it is a variable name. So a copy of n is created here, and this number 5 which is here is copied again here. So you have a local copy of n, and items here is referring to the copy of items in the main. Are you getting this point?
But the memory of n is different, right? In the
Yeah, in the function memory of n is different. If I make, see here, before I return, if I say n equal to n plus 10, that change will happen here. It will not happen here.
okay.
You got this point?
Yeah.
Whereas if I do like this, before I return, if I say items of 2 equal to 7, then items of 0 is this, items of 1 is this, items of 2, which is 8 here, which is 9 value, right?
9.
So this gets changed to 7
Okay.
because this items is referring to the copy which is there in the main function. You get this point? So when you pass arrays, you are passing the address of the array. You are not making again a copy of this all these elements in the function. Right? So that is how you save memory. Otherwise, what would have happened? You would have had a separate copy here, wasting memory, isn't it? Let us say all these 5 elements take some 20 bytes. So again, 20 bytes have to be allocated just to compute the sum. Okay, so that is why in C, this is called call by reference. It means you are getting only the address of the array, not the entire array into the function. Whereas this is called by value, because you are sending only the value. Is that point clear?
Yeah.
Okay. So if I were to make n also call by reference, what you would have done? Any guess?
Point star.
Here it should be star, right? And here it should be ampersand. Now this n will contain 4016. It will reference this location only. You get this point?
Now that star will become a pointer.
Yeah, this will become a pointer now.
Okay.
N
Sir,
will,
can you repeat it? Sir?
yeah. Now you, in the earlier case, n was a normal variable, right? And you had a copy of n here. You had pi only.
Correct.
Now, if I want to refer to this n from being in the function here, it means it should be called by reference. I have to make this as int star n.
Okay, in my main function, the n is a pointer.
Yeah, in the function, instead of n, you put star n, and while invoking the function here, you should pass the address of n, not just n. So here you should pass address of n. So in this case, what happens? This address of n is passed here. So 4006 is copied into n. So that this n refers to 5. Now if I do star n equal to star n plus 5, then this n will be changed to 10. Correct? Okay, so call by reference, call by value depends on you. If you don't put star n here, it is call by value. And if you put star n, it is call by reference. So now we don't require to change value of n. It is better to use call by value and keep this value n intact. You just want value of n to count how many elements are there, right? You are not modifying n. Similarly, you are not modifying items, but in case if you are required to modify the items, let us say each element has to be multiplied by some constant and then copied into sum, you could have done that. So it all depends what you are doing in the function, and call by reference will modify the original content in the called function. So much is clear? Okay. Yeah, so these are some deeper aspects. I guess no books will cover this, but as an experienced programmer, you should know how the function call happens when it is called by reference using an array name and when it is called by value. Okay. All right. Now one small thing is remaining in functions. That is, we have seen variables of different types, and with types we have modifiers, long, short, like that. There is one modifier called as static. We shall see what is the meaning of static variable when we are using functions. Okay, so let us say we have a function called as counter function, something like this. You are not passing any value here. Okay, so the purpose of this function is to count how many times this function is called. Counter function, we keep it as singular here. Now I want to count how many times this function is called. So what I would do, I will take a counter variable here, initialize to 0. Every time you call, you make counter plus plus, right? And display this counter function. Yeah. Now I am called one time, correct? If I call it again, it should print I am called one time, and again after that it should say I am called second time, like that. Let us see whether it is happening. I'll put one slash n so that. So it is again saying I am called one time only. It is not saying I am called second time.
Correct.
Okay. So if I want to retain the value of the counted value between function calls, then you should declare this as static. If I declare static int counter, only once it is initialized to 0, first time when it is called. Then subsequently it will skip this step and then go to take the previous value and increment. Now if I run the program, it will say I am called one time, I am called two time. Then again if I call, it says I am called three time. Do you see this? So static.
Sorry, because void will not return, hence it is again getting set to 0, and we will get same value if we don't give it static.
Pardon?
Void doesn't return anything, right?
No, why it doesn't return anything? I am not getting the returned value. The incremented value of counter I am printing here and just coming back.
Okay.
But between, this is first invocation, right?
Yeah.
This is first invocation. This is first, this is second, this is third. Between the invocation, the value of counter is not reset to 0. It will retain the whatever value that was there.
Okay.
If it is declared as static.
Static.
Okay. So static variables retain their value between invocations. Okay, so this is one very useful concept, and many times you require this in a situation where you want to find out how many times the functions are called if it is a big project. So you have to declare a static counter. Okay, static doesn't mean constant, that you should remember. Okay, so static means it will retain the value that you executed previously or incremented previously and then print it. Fine?
Yeah.
Okay, so this is one useful concept that you should remember whenever you're using functions. Okay, between function calls, if you want to retain the value, then you should use a static variable inside the called function. All right?
If this particular counter, if I want to use it in the other functions, then can I use it?
Yeah,
Because
yeah.
it is-
You want to pass this value to another function?
No, I want to use the same counter. I just, whatever that it has been initialized, can I use it some other function by name void decrement the function, meaning decrement the counter.
Then that will be a separate static counter there.
Okay, okay.
It will not be
So
this one.
it will not be in the scope of
No.
this other decrement counter
No,
function.
it will not be
in
this
the-
one.
Okay, okay. Even though the name is same, but it will not be in the scope of this one.
Yeah.
Right.
Okay. Now, one last thing that we have worked with arrays, so functions can be used with character arrays also, no? So char my name square bracket, let us say Ajay. So can I pass this string to a function? Should be possible, right? Int n
Yes.
compute length. So if you want to find the length of this string, then I can do that within the function. So here I would write int compute length. So what would be the argument here? Char
Char star.
my name square bracket, or you can say char star my name. Anyone is fine. Hmm? So if you want to find the length of the string, you take one variable int I. Okay. So while my name of I
Of I is not equal to null.
not equal to null, you know how to do
I
that whole thing, right?
I should be 0.
Yeah, I should be initialized to 0, otherwise you'll get some garbage and it will go out of the range. And just say return I. And if I printf percentage %d, it should print the length of the string. And you should write the function prototype here as int compute length char star.
A return spelling,
Hmm?
31 line
Yeah,
return spelling.
yeah. Hopefully, yeah, 4. It should be n equal to 4. Okay, so it is doing that. So we can pass the array of characters also as an argument to the function and manipulate it within here. Is that clear?
Yes.
Okay, good. So today we have covered major aspects of functions, how to write functions with arguments, without arguments, and with return type, without return type. And also we saw how to pass the arrays. And when it is passing by arrays, it is called by reference. Okay, and it is useful sometimes to save memory. And we saw static variables inside functions, which will help us to remember the old value of the variable between function invocations. Okay, so we shall stop here with our discussion on functions, and we shall continue in the next class.